Hello again. So we ended the previous video with an open question. You were tasked with converting 1 meter per second to miles per hour. Essentially, we're trying to come up with what number goes out front. What number of miles per hour is equivalent to 1 meter per second? And so let's look at how we make such unit conversions. Well, the first task is coming up with equal ratios so that we can start shifting our various units. We know that we need to understand how to get meters to miles, and we need to know how to get seconds to hours. And so let's come up with the various equalities that will get us there. Well, you can look up or might already know that 1 hour is equal to 3,600 seconds. Now we can't just swap out 3,600 for the 1 hour. We'll do it in a similar fashion. You'll see in just a moment. We can also look up that 1 mile has 5,280 feet, and that 1 meter contains 3.28 feet. Now, with all these equalities, we can set up some ratios that are 1 to 1. This is 1 to 1, really. It's 1 to 3,600, but these are equal. That means if we made a fraction with 1 hour and 3,600 seconds, they're the same. One number divided by itself is 1, and so we're going to set up a unit conversion like this. So we start with 1 meter per second. That was the units we were given, and we are going to now set up a bunch of ratios here to convert those units. To properly do this, you need matching units on top and bottom. If they're on the top and bottom, they will cancel out. So first off, I start by canceling the seconds. If my seconds are on the bottom here, I need to put them on the top here. And so I put 3,600 seconds on the top, and I know that that is equal to 1 hour, so if I divide it by 1 hour, this whole piece is equal to 1. And that's what I will do this whole time. And what happens when you multiply by 1? You don't change anything. So we're not actually changing anything but the units. And of course, we'll see some numbers shift, but we're not actually changing the physical amount. We're going to end up somewhere that is exactly equal to 1 meter per second. We're just going to describe it slightly differently. So seconds on top, hours on bottom. Well, we also need to cancel those meters. So let's put meters on the bottom. 1 meter was equal to 3.28 feet, so we can put that on the top. Well, that's going to get us to feet, but we want to end with miles. So feet are now on the top. So we need to put something with feet on the bottom. 5,280 feet are equal to 1 mile up top. And we can see that seconds cancel with seconds. Meters cancel with meters. Feet cancel with feet. And what are we left with? Well, on the top, miles. And on the bottom, hours. You then multiply or divide these numbers out. 1 times 3,600 times 3.28 divided by 5,280, and you get your answer, 2.24 miles per hour. That is what 1 meter per second is. So now whenever we have a problem and you're asked about something in meters per second, if that doesn't feel intuitive to you, you can quickly convert to miles per hour so that you can better picture in your mind what's going on. So, as I said, we're going to use this a lot, and I would call this just 2 times more, or a little more than 2 times, because it's 2.24. So if I gave you a simple question like this, if something is moving 30 meters per second, it is A, walking, B, driving, or C, a rocket to the moon. Well, before this, you might have had no clue how fast 30 meters per second is. You might try to picture in your head, okay, 30 meters, that's maybe like a football field. And they're covering a football field. Well, that's not a football field. That'd be about 100 meters. That's, 30 yards on a football field. And you're covering that in 1 second. But instead, we can just multiply that by 2, 60, maybe plus a little more, like 70 miles per hour. Well, 70 miles per hour, I can't walk that fast. A rocket to the moon is definitely going faster than 70 miles per hour, but that is a perfectly acceptable speed to be driving. This quick mental conversion will help familiarize you with these metric units. All right, now let's talk about another thing that physicists like to do, and that's called dimensional analysis. It is looking specifically at the units. Dimension's kind of another word for units. So how can we learn something about a problem just looking at the units? Well, I'll show you. So let's consider Einstein's energy mass equivalence relation, E equals mc squared. Didn't think we'd be doing this on day one of physics, did you? Well, we are, so let's take a look at it. The unit of energy is the joule. Remember, we're just really looking at the units with dimensional analysis. The joule is a derived unit. It is built of kilograms meters squared per second squared. Well, I like to use these little brackets around variables to say this is their units. So the units of m, that's mass, are kilograms. The units of c, that's the speed of light, are meters per second. And of course, if we square it, we square the units. So the units of c squared are meters squared per second squared. So we can check and see if this equation even makes sense from units. Are we actually comparing apples and apples, or are we trying to compare apples and oranges? Well, if we look at the units of mc squared, that's the same as the units of m times the units of c squared. M gave us kilograms, c squared gives us meters squared per second squared, and sure enough, if we compare that to the units for energy, they're the same. And this type of connection is what helped inspire Einstein to make this equation. Just because the units match doesn't mean it is certainly a physical equation, and there's other things that go into here. You know, you can add numbers. Numbers don't actually have units. If we just threw like a multiply by 2 on here, that's not the same equation, but the units would still match. But these are clues out there in the universe to come up with connections, and this is one of the biggest connections ever made, that there is a connection between mass and energy, that they are actually kind of one and the same, and that energy can turn into mass and mass can turn into energy. All right, let's look at another example. So in our first chapter of real physics, or chapter 2, we're going to look at motion. And so here's a few quantities we'll study. Acceleration, which we give by the letter A. It has units of meters per second squared. Velocity, units of meters per second. And displacement, which has units of meters. So let's look at some pretend equations, or maybe they're real equations. Who knows? We'll find out. Does the equation V equals 2AD make sense simply from a dimensional analysis standpoint? Well, the units of V are meters per second. We've already been given that. What are the units of 2AD? Well, the units of 2AD are the same as the units of AD. That 2 doesn't add to the unit. It's just a number, a constant out front. Well, the units of A times D are the units of A times the units of D. Units of A are meters per second squared times units of D are meters. Meters times meters is meters squared per second squared. Well, that is not equal to meters per second. They're close, but these are both squared. That is definitely different than both not being squared. So this equation, we can immediately say doesn't make sense. It cannot be true. Well, how can we adjust it? What about V squared equals 2AD? Does that make sense? Well, we found that V was meters per second, or we were given V as meters per second. If we square it, sure enough, meters are squared, seconds are squared, and it matches 2AD. And in fact, this does look similar to an equation we will work next chapter. This is the type of thing that physicists can do to have an idea if equations will work before even trying. And it can make cool connections like Einstein found between energy and mass. So I hope you found that pretty interesting. Dimensional analysis is great, and this is one reason I will always encourage you to write your units. If the unit of your answer doesn't match what it's supposed to be, you probably made a mistake. All right, so that's going to be the end of this video on units and dimensional analysis. We'll come back with one more for this chapter, which will cover exponents, scientific notation, and touch a little bit on significant digits. So I will see you guys next time. Same bat channel.